All right, question number 8. So in the previous, we're going to be using the conjugate to help us solve this question. So this question reads, how do you simplify 3 minus 2i divided by 3 plus 2i? Okay, so we're going to use the idea of a conjugate. So let me explain to you guys again how the conjugate applies here. So we want to get rid of the complex number in the denominator. That will help us simplify our solution here. Okay, and before I told you guys that a plus bi times its conjugate, a minus bi, equals a squared plus b squared, right? So it gets rid of the imaginary component altogether. So we're going to use the same principle to help us to simplify. So first, I'm going to write down my expression here, and we're going to multiply this by 1. Okay, so multiplying it by 1 will give us the same answer, right? So I'm going to rewrite this 1 in a different manner. So 3 minus 2i, so this is our original expression here. So I'm going to rewrite 1 as the division of the conjugate of the denominator, which is going to be 3 minus 2i over 3 minus 2i. Right? So this is still equal to 1, right? So we're not changing anything yet. So this is a valid way of manipulating our equation. However, as we multiply this together, we notice that this denominator now is going to be 3 squared plus 2 squared, right? So by doing this, we get 3 minus 2i times 3 minus 2i divided by 9 plus 4. So let's expand the numerator here. So we have 9 minus 12i, I believe, and then plus 4i squared. Okay, divided by, I'm going to simplify the denominator, which is 13. Okay, and now we're going to, so I squared, like before, we know that I squared is equal to negative 1. So by doing that, we know that this is going to be negative 4, and we get 9 minus 4 is 5 minus 12i divided by 13. Okay, and to rewrite this, we're going to rewrite this in its complex number form, which has a clear and real number component and an imaginary component. So this will equal to 5 over 13 minus 12 over 13i. So we have simplified this beginning expression by getting rid of the imaginary components and the denominator and simplifying it in a way that the real number component and the imaginary component is very clear to us. So this solution is correct. Good work. Okay, cool.